Okay, yeah, let's get started. So, so, I hope everyone is aware of Python programming language. Hoping that I'm starting with the statistics part. So, what is basically statistics? Why are we learning statistics first of all? So, we all might have studied in your school math, and also in college, you would have definitely had statistics paper. Like if you have studied BCA or BE computer science and so on. So statistics is a science concerned with developing and studying methods for collecting, analyzing, interpreting, and presenting data. The first thing, I don't like to follow any documents, and I hate PPTs. So mostly I'll be giving the content from my side. So this document and PPT, whatever I'm sharing it here, just for the reference sake, like just sticking to some notes or something, but generally I don't like to showcase something. I always go with my own handwritten notes, whatever the case it is. So statistics here, they mentioned it as for with developing and studying methods for collecting, analyzing, interpreting, and presenting data. So collecting, you're going to collect the data, analyze it, you're going to do some interpretations on the data, and you're going to present the data. So with this thing, you are able to, so basic, see, you can observe now, like everywhere this machine learning and artificial intelligence is taking place. So whatever maybe the thing is, the things are getting updated with the data everywhere, right? Everywhere the data is getting generated in lakhs, and tons of data is getting generated for every second. Like either it could be a call flow, like you're talking to someone over the phone, there is some amount of data is getting generated. You're making an order in online, your credentials means the what are the products you purchased, how many quantity, quality, and what is the price, tax applied, GST applied. So any everywhere in real time, if you see, the data is getting generated, and we are trying to observe the pattern, and what pattern does the data follows, where at what time the customers are mostly making an order, or during the sale, or during the night time, or during the daytime. So depending upon the customer behavior, that particular client, maybe the Amazon website or whatever it is, they try to increase their business depending on the needs of the customers. So if the customers are not satisfied, then then no use in taking forward that business. At the end goal, whatever the business it is, the customer has to be satisfied. So this is in the real time. Like if you're working in XYZ corporate, we'll also be having our own applications running it. We'll be running some application in our organization. There also some kind of data which will be keep on getting generated. Either it is a positive case or negative case. Even if it is positive, we are going to get that that particular test case is passed executing the flow. Or if it is fail, you're going to get some error logs, like which is telling you to point out the root cause why that particular test case has failed. I'm just telling in the layman terms. So like if you are guys are working in some corporate, like, or you're going to enter into some corporate, you'll get to know like the flow, like how. But you can always think of like the real time, like when you're entering a mall, say, there's a sensor which is detecting the human, and it is opening the door, and also it's basically reading every time, it is also storing the information. So everywhere your information is being tracked. When you enable your Google location, you will, at the end of the every month, you'll be getting a report like that you have been traveled so far and so on, so places. So everything can be tracked. Okay, so here basically in statistics, what, when we get the raw data, what is the insightful information can I get out of that raw data? Say I have a 60 students, if I just take in a class, say we are of class BTech computer science first year, and you are studying under me the machine learning course. If I have all 60 students marks of machine learning, what is the information I'm getting out of it? I wanted to know who is the first mark, what is the maximum value if I say the first mark, the minimum value, what is the average of the class. So when I want to compare the section A and section B, I want to compare the means of the two classes, or the first mark of the two classes. Until unless some calculation has been calculated, I cannot come up with some or some analysis. The 60 students data is just a raw data I have. Maybe it's a pre-processed data, whatever you can tell it as. If I want to come up with some insightful information out of it, I want to basically analyze the data and come up with some metric which will basically tell the overall data. So you're going to collect the data, analyze the data, you're going to come up with some interpretations and present it. So this is what you can do with statistics. Post that, if you wanted to do further research on your data, that's why we do have this machine learning and deep learning and so on. So we'll be discussing over the period of time. Now let us understand uh, just a minute. Yeah. Okay. Uh, okay. So first we'll discuss about the three important metrics, measures of the concept is called, the concept name is measures of central tendency. Since the institute told me to keep this banner, I have to keep this. They can do. Okay. So first concept today we are going to discuss about measures of central tendency. Sorry for my bad handwriting. I'm trying my level best to write it very neatly. The first we are going to discuss about the mean, median, and mode. Sorry if you guys have already know about this mean, median, mode. But we'll quickly brush up this and we will go for the other level concepts. So this mean, median, mode, you might have already come across these concepts in your school, maths, and college as well. But now we are going to understand why this is really helpful and what is the significance of it and why are we using it. So when it comes to mode, so let us go to mean and median later. Let us understand what is mode. So mode is basically used when you want to find out the frequency, like how many times a particular element has been appeared in the document, which one has the highest frequency. Okay, so like given a basket of colored balls, like if I want to find out like the ball which has appeared more number of times, something. Okay, when it comes to the mean and median, both are the metric is used to find out the average. Let us first understand the mean. So we generally know the mean is basically used to find the average, right? Like given a set of 60 students, machine learning mark, if I can just go sum everything, I can go for divided by 60. Then why do you have median when there is a mean which can does when it can do the operation, average operation? In such cases, okay, let me tell you what does it mean. So the first and foremost step we have to follow for median is the data should be sorted. You should sort the data in ascending order or descending order. Ascending means from lowest to highest. Descending means from highest to lowest. Picking up the middle element. If you have odd number of elements, if you have 5 elements, picking the third is your answer. If you do have even number of elements, picking n and n plus 1, then you will take the two numbers and then you take the average. Okay, this also serves a purpose of averaging. Then what makes different compared to mean? Guys, please listen carefully. When you have outliers in your data set, going with the median is the best option. So you might be thinking, what is this outliers? Say you are developing an application. What the instrument can be anything, or it could be the application which you design in your, like whatever you're working there. You're designing a system in such a way that minus 30 to plus 30. The application can only produce the values from minus 30 to plus 30. Okay. If in case your system is producing something like 200, or minus 31 or something, then this is not part of your application data. These data points are basically called as outliers, which is irrelevant to the information. Sometimes the irrelevant information also is needed. I'll also come to that point. This is one example. Say, if I wanted to calculate the average salary of an organization, like say some XYZ corporate company, I just wanted to know the average salary. If I take the employees, I do have intern in my organization, here for and so on, so on, so on. So like product architect, product owner, tech lead, and so on, so on. And I'll be having finally the CEO of the company. This is the hierarchy has been followed in every organization or based on the job grade or whatever. If I take the intern salary and also the CEO salary during my calculation and coming up with the average salary is the correct value guys, I might be getting some 30,000 per month. My CEO might be getting some, just I'm telling, he might be getting some 6 lakhs per month. But my average salary is coming out to be one. The confluence of these CEO salary into the calculation, the total average is getting deviated. So I should basically remove this maybe 1 year as well as the intern salary. I have to remove from here and also remove this the CEO and so on. So persons from the extreme right and extreme left. If I remove, then I can go for mean. If I'm not removing those data points, but still I want to go for finding the average. For these kind of data, going with the median is the best option. Make sense? Able to understand? Until unless you guys respond, it will be very difficult because this is a virtual class. I cannot see your face also.
Can you please explain with some other example,
For
if
which one?
possible? Median.
See, median is applicable when you have outliers in your data set. Say, if your application can produce only this from this level to this level of data, if you do have some noises, say, to put in other terms, say when you're floating some a Google form for the people to fill it, okay, if you're not specific, if you're not specifying what to be filled or something for that column, like people might fill it in their own way, which introduces a noise or the outliers into your data set. In such cases, you have to keep track of the outliers because that may mislead your calculation, right? So when you are having outliers in your data set, going with the median is the best option. Uh, like who asked that question?
Yeah, me.
Yeah, Monica understood.
Yes.
Yeah, thanks. I hope mean median mode is clear. I'm moving to the next topic called measures of dispersion. So we'll be discussing about range, standard deviation, and variance. So the range is basically the maximum value minus the minimum value. In what range does your data falls in? If you wanted to understand, you basically go for the range. Okay, that is simple. I'll go for the standard deviation and variance. Standard deviation is the normalized form of variance. Okay, let me first of all tell what is the definition. Say I have data points. I'm just plotting here and there. Okay, you can consider it like XY coordinate or X coordinate or whatever it is. And my range, and my average falls here. This is basically called as average. The average of the data points. Say I have the height column of 60 students. I'm basically plotting all the 60 students height, and also I'm plotting the average of that 60 students. Standard deviation is defined as what is the variance, means how much deviation or difference is there from the average to the every data point. Basically, what is the distance or variation from the data point to the average value of that particular data points. That is basically called as variance. Square root of variance is basically called as standard deviation. That's why they say it as the normalized value of variance is basically called as standard deviation. Guys, able to get it? Say your height is some 156 centimeter or something. The average is say some 145. So the difference between 145 and 156 is 11. So that is basically called as variance. And it may changes according to every other data points. And you will calculate and finally come up with some some value. That is basically called as a standard deviation. You calculate between every data point the variance. That is the formula like x minus x bar. Okay. Guys, able to follow or any doubts?
No.
All good, right?
Yes.
Okay. You can stop me then and there if you feel uncomfortable or you're not able to follow. Okay.
Okay, sure. It's the same
Sure.
for you.
Thank you. What else I have to discuss? Okay, I'll go for the types of data. So the next we are going to discuss about the types of data. Okay. There are two types of data. One is basically called as a numerical data. The other one is called as a categorical data. This numerical data is otherwise called as quantitative data. This is otherwise called as qualitative data. This is again further divided into continuous data and discrete data. And this again further divided into nominal data, ordinal data. Okay. So these types of data is further classified into two types. One is numerical data and otherwise called as quantitative. Categorical data otherwise called as qualitative data. Let us understand the difference between these two data types. So as the name itself indicates a numerical data, let us understand what is this continuous. Just guys think of, if I want to reach from the number 1 to 2, there are infinite numbers in between this. Correct? Like 1.1, 1.00001, 1.0002, 1.00011, 1.00012. So like we have infinite numbers from between the range from 1 to 2. Agree?
Yes.
Yeah. And there are few metrics which will fall under this category. Say the weight of a person, it can be 59.27362 or something. The temperature, the body temperature or weather temperature, whatever it is also will be in the floating